Hi there, and welcome to this lesson. In this lesson, we'll be learning systems of equations, and we'll be learning to solve systems of equations by method of elimination. Now, as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch, okay? We would be more than happy to help. Okay, let's jump right into the lesson. So systems of equations elimination. Now, what is this about? We're looking to solve systems of equations using the elimination method. What is the elimination method? Now, consider the set of simultaneous equations, okay? And then basically we have 2x plus 3y equals 5, and we have minus 3x plus 2y equals minus 41. Now, we're going to solve this set of simultaneous equations by method of elimination. I'm going to introduce this method to you now. Basically, I label the equations, label them equations 1 and equations 2. And now, the elimination method. Now, when you're solving simultaneous equations or systems of equations using the elimination method, the first thing you want to do is you want to select a variable. Okay, now when you're working with substitution, you select an equation and a variable, but in this case we're selecting a variable, i.e. we'll be working with both equations. Okay, and right now I'm going to select y. Okay, I'm going to be working with y, and next thing you want to do is you want to scale the equations to make the coefficient of the selected variable equal. Now, what is this about? Basically, think about this. If you had x plus 1 equals 4, okay, or x plus 1 equals 5, and basically looking to solve for x, you would have x plus 1 equals 5, x equals 4. Now, what if you multiplied everything in that equation by 2? So x plus 1 equals 4. I'm going to multiply everything by 2, so you have 2x plus 2 equals x plus 1 equals 5. I have 2x plus 2 equals 10. Now, if you solve that equation, you still arrive at x equals 4. Now, the idea is that if you have an equation, basically, you can scale that equation by pretty much anything. If you multiply every term in that equation by a constant, okay, you can pretty much scale that equation by pretty much anything, and the equation will still maintain its properties. It will still stay the same, okay? And basically, if you solve that equation, you still arrive at the same answers. So here's what we're going to do. We're going to scale the equations, okay? Like I said, you can multiply these equations by anything and they would remain the same. And so what we're going to do is we're going to multiply the equations by certain numbers, okay, to get the variables, the coefficient of the selected variable equal. So we want to have the same coefficient for y in both equations. At the moment we have 3y in equation 1 and 2y in equation 2. Now here's what I'm going to do. I'm going to multiply equation 1 by 2, okay, and I'm going to multiply equation 2 by 3. And when I do that, I end up with equation 1 by 2. I have 2x becomes 4x, 3y becomes 6y, 10 becomes 20. Okay, and equation 2 by 3, I have minus 3x becoming minus 9x, 2y becomes 6y, and basically minus 41 becomes minus 123. Now, if you look closely, we now have equal coefficients for our selected variable y, i.e. we have 6y in equation 1 and we have 6y in equation 2. It's very simple. Basically, if the coefficient of your variable in the second equation is 2, you multiply the first equation by 2. You basically just switch them around. So yeah, now that we have that, the next thing we're going to do is we're going to subtract equation 2 from equation 1, and this is pretty much where the name comes from. We're going to eliminate y, and here's how we're going to do it. We're going to subtract equation 2 from equation 1, okay, and basically subtracting, we have 4x minus 9x, okay, it gives us 13x. Now you need to be very careful working with negative signs here, okay, because this process is actually very prone to errors, particularly if you're not very good at working with negative numbers. So you need to be very, for example, 4x minus 9x is 4x plus 9x, i.e. 13x, okay, and then you have 6y minus 6y It gives you 0. We've eliminated y. And then you have 20 minus 123, you have 143. And basically what you have in the end, if you have the 13 plus 0 equals 143, we have eliminated y. Okay, we can now go ahead and just say 13x equals 143, and we have that x equals 11. Simple. So we found our first unknown, and now we're going to go ahead and solve for the second. And basically to solve for the second, you just put that answer into any of the equations you have there, and then basically you go ahead and solve, and you end up with y equals -4. So x is 11 and y equals -4. Very simple. So the elimination method, you select a variable, okay, and then you scale the equations to make the coefficient of the selected variable equal. You subtract equations 2 from equations 1, and when you do that, because the variables are now the selected variable is now equal in both equations, you get 0. When you subtract equation 2 from equation 1, you end up with 0, i.e. you would eliminate that variable and you'd be left with a simple linear equation involving just one variable. Okay, so you have 13x equals 143, and when you have that, you just go ahead and solve, divide both sides by 13 and so for x, and then you have your x value. You just go ahead, put it into either of the equations, and you have your y value as well. Okay, so I have this example here. Let's do just one example, and basically we have solved the set of simultaneous equations using the elimination method. And basically we have 2x minus 5y equals -6, and we have minus x plus 3y equals 4. Now equations 1, equations 2, we're going to select a variable, okay, and I'm going to be working with y again. Okay, it's easier to work with, and I'm going to scale my equations to give me equal coefficients for y in both equations. And looking at this, I think I'm going to multiply equation 1 by 3, and I'm going to multiply equation 2 by -5. Okay, and like I said, careful with your negative numbers. Multiplying equation 1 by 3, I have 2x becoming 6x, minus 5y becoming -15y, -6 becoming -18, and for the second equation I have multiplying that by -5. I have minus x becoming plus 5x, I have plus 3y becoming -15y, and I have 4 becoming -20. And now that we've done that, we just go ahead and subtract equation 2 from equation 1. And basically we have 6x minus 5x, it gives us x, minus 15y minus -15y gives us 0, and minus 18 minus -20 would give us 2. And if you just extract that out, you have that x equals 2. Now we have that x equals 2. We're going to solve for y, and we just pick either of the equations there. Basically we have 2x minus 5y equals -6, and we've been told that x equals 2. So basically we work that, and just put that into your equation, and you should end up with y equals 2. And yeah, that is how you solve a system of equations using the elimination method. Very simple, very straightforward. Bye for now.